Hello guys. So today I'm going to talk about lesson 3-3 transform linear functions. Alright, so this is after fall break. Welcome back you guys. So this is the first lesson. I'm sure you forget the warm-up already. So we did it, this question we did it before you went to fall break. Okay, let's go ahead and review that one first. This is a linear function. It says to write a linear function, which we are going to make a function for the data in the table. To do that, I said something that you remember like your name. That's y equals to mx plus b. So you have to know this one to be able to find the function. So this is an equation like this. Let's change it to and make it a function. So we put fx and it looks way better. So what do we need? One thing we need slope, the other thing we need b. So we are going to find them one by one. Let's go ahead and find the slope first. So everybody know the slope formula? That's y2 minus y1 divided by x2 minus x1. We can also say that change in y and change in x. There you go. Let me highlight it. What I mean with that, y2, y1. So those are the like first term, second, third, fourth, and so on. So this one going to be x1, x2. That can go x3. It doesn't matter. That can go x4, x5. And this one is y1, y2, y3, and so on. So all I need is y2 and y1. So let's go ahead and substitute those. M equals to y2 is 90, is right here, minus x2 is 60, divided by x1 is 1, x2 is 1, x1 is 0.5. And when you do the calculation, that gives you 30 divided by 0.5, which is 60. Now we get slope as 60. Let's write our function again. Y equals to, slope is 60, 60x plus b. Still we don't know the b, so we have to find the b. We need 2 points for x and y. We can get the points here, whichever point you like. 190 if you like it, you can take 2 or 150 or like 0.5 and 60. Usually we choose the easy one, so 1 and 90 looks easy for me, so I'm gonna take this one. Let's substitute x for 1, y for 90, okay, so it's going to be 90 equals to 60 times x is 1 times 1 plus b. We all know 60 times 1 is 60, that is why we don't need to put 1. So this minus 60 on both sides, they cancels each other, and what we got is here 30 equals to b. And now I take this b and replace with this b, and we delete that one and we put 30. There you go. Now we have an equation. It says the function. Let's change the function notation. That's going to be fx equals to 60x plus 30. This is our answer. Okay, good. Let's move on. So today's lesson was transforming. Okay, that's good. Pretty much it for today. We don't need this one. Transforming linear functions. We have three options. The linear function transforming means we are going to move the function on the coordinate plane. We will have a function going like this. We are going to move this up, down, or left, or right, or we are going to rotate it. Let's see them all three in one. So let's start with up and down. So we have a parent function, and let's call this function fx equals to x plus 1. And from here, let's move f function 2 units up. So if it's 2 units up, the new function is going to be like this, from 1 to, so it's going to be here, This one was the f, this is the original function. So this new function is going to be g. That's a new one, that's why we name it a new name, we put g. Alright, so this g function is going to be here. How is going to change? This g function is going to be 2 up, right? So that means the y-intercept is going 2 units up. So we have the parent function, we call this parent function. This parent function now has a kid because we have a new one, so we move it up and we get a new function. So this is going to be fx plus 2 up means plus 2. So here is what we get. If you want to substitute fx with x plus 1, then you can see what is gx without fx. So gx equals to fx, we know is x plus 1, I put x plus 1, plus 2. And that gives me gx equals to x plus 3. There you go. Okay, now other option is move f function 3 units down. If you move it 3 units down, they're going to be 1, 2, 3. So this is the point. We will get a new function that's called, the parent function has another kid, let's call it with h. So hx equals to, this time is going to be fx. Since it's going down, so going down 3 units, so we put negative 3. That's it. This is the going down. Alright, so pretty much it is. The next one is right and left. So now on this one we are going to see how it's going to change if you move the function, the graph to the right or left. So let's have the same function. So this function defined as x plus 1. And I'm going to move that function 2 units right. And let's see what's going to happen if you move it 2 units right. Here. So from here, 1 and 2. And let's graph it. It's going to be parallel, the same slope, everything is same, so I'm going to call it G. Okay, so as you see that going down also, right, means that also goes 2 units down. Then let's see how it's going to change on G function. So Gx equals to f x minus 2, this is in parentheses, and this is all you need to know. Let's move that function 3 units left. So the 3 units left, there will be 1, 2, 3, and the function is going to be look like this. They all parallel, by the way, they all have the same slope. And this new function called h, so hx will be equals to f. So as you can tell, now it's left. When it's right, we put minus. When it's left, it goes up, so that's plus. So x plus 3. And that's it. Let's move on to the next one. This time we say stretch and compress. And this is the last one. Here's our parent function. Let's say have the same function, fx equals to x plus 1, same as the others. And now let's stretch this function by scale factor 2 and see what's going to happen. Now gx is going to be, if you stretch it vertically, that will be going more vertical, more steeper, and the function is going to be super easy. You just multiply by 2, and if you compress f function by scale factor, by scale factor, and then this time the function is going to be less vertical, which is look like that, and this function hx is going to be equals to 0.5 fx. As you see that if it's going down like that, less vertical, so that's the number is between -1 and 1. So that means like the number is always with the 0 point something. So 0, let me write it down here. 0 point. Okay, guys, that would be all for the lesson. I hope you see you next time. And we have a big boom.